Okay, so you guys had the quiz from yesterday. I just got back to you. Now that you've got the quiz back, a couple things I want to say. First of all, the scores on the first quiz are always pretty low. It just takes a while to adjust. So if you didn't do as well as you think, don't get too down on yourself. Second is, now that you have it back, you are allowed to do corrections. You're allowed to redo the problems you got wrong. Now for corrections, what I require, like I said, redo the problems you did wrong. But as you redo them, normally on a quiz, I don't require you to show your work, but when you do corrections, you must show your work. Basically, what I'm asking you to do there is to prove to me that you actually did redo it and you understand how to do it right now, and that you didn't just look at the person next to you, see the right answer, and write it down. Okay? You will get back half your points. So this was worth 9 points. Let's say you scored a 5 on it. If you redo those problems and turn them back in, you get back 2 points. You end up with a 7. 7 would be like a C minus, yeah. Any questions on the quiz? Yes. I would like you to look at them for a little bit first. When you come in on Monday, if you still haven't, or not Monday, but on Tuesday, if you still haven't figured out what you got wrong then, let me know and I'd be happy to go over them with you. But I'd rather you look at them and see if you can figure it out on your own first. Any other questions? Make sure you do those. Even if you had like an 8 out of 9, you're only going to get back half a point, but it's still half a point. Throughout the semester, we have 20-some quizzes. A half a point on each of those quizzes can be 10 or more points. That adds up by the end of the semester. So make sure you are doing those and getting those points. Okay, so for today, we're continuing on what we started yesterday after the quiz. We looked at the structure of fractions and converting and renaming fractions. So today we're going to look at what are we going to do with something like 1/4 plus 3/5. We've mentioned before that we can only add or subtract things. When we add or subtract, there's two special things. One, we need the same name, right? I can only add things that have the same name. Right now, 1/4 and 3/5 have different names, different denominators. So we can't add them the way they're written. The second thing about adding and subtracting is we're going to combine the counts, because we always combine the counts, but we're going to then keep that same name. So for fractions, that first one, needing the same name, means we must find a common denominator. Which means our first step is figuring out what that common denominator is. Well, there are a couple of strategies. There's actually 3 or 4 ways of finding it. I'm going to show you, only going to show you a couple of them for finding a common denominator. First of all, a common denominator can always be found by multiplying the denominators. For this problem, that would be just the denominators of 4 and 5, which is 4 times 5 is 20. The issue with that is it might not be the least. Might not be the smallest denominator. We've always been told you have to find the least common denominator. It's not necessarily true. It's easiest if you find the smallest one, but it still works if you use a bigger one. So if you're stumped and have no clue what the denominator, what that common denominator should be, you can always just multiply the two denominators. Next, the other one is to make lists. I'm going to start out with the 5 because 5 is really easy. I'm going to count up my 5s. It'd be 5, 10, 15, 20, 25, and so on, right? Let's go with the 4. It would be 4, 8, 12, 16, 20. There's our first match. That is our least common denominator. Now there are other methods. There's factoring methods and stuff like that. We're not going to take the time to look at them. But if you are struggling with finding that common denominator, come talk to me. There are other things I can show you that are a little more time consuming but might help you find those common denominators. So we know that our common denominator here is going to be 20. That's what we're going to use. I tend to add and subtract numbers vertically like this, so I'm going to do the same with my fractions. 1/4 and 3/5. My common denominator, we just said, is 20. Now, if you remember from yesterday, to change the name of a fraction, we have to figure out what do we multiply that old denominator by, in this case 4, to turn it into the new one. So what do we multiply 4 by to make it 20? 5. So what does that mean we have to do? Multiply the numerator by 5. So 1 times 5 is 5. Down here, what do we do to the 5 to turn it into a 20? Times 4. Right? So we have to do 3 times 4, which is 12. So we have now given them the common denominators. Next, we're going to add. Remember, when we add, we combine the counts. So that's 5 plus 12, which is 17. And we keep the same name. So we just keep the 20. Any questions? What if I have something like 3/8 plus 1/6? Let's say we are looking at that and we have no idea what the common denominator is. Let's go to the fallback. What is 8 times 6? 48. There we go. We can use 48 as a common denominator. It's going to work. What do we multiply 8 by to get 48? 6. So 3 times 6 is 18. What do we multiply 6 by to get 48? 8. So we multiply 1 times 8 is 8. We've got our common denominator. We combine the counts. 18 plus 8 is 26, and we keep our same name of 48. Now that is a correct answer, but we should simplify it. How can we simplify that? Divide them both by 2, right? 26 divided by 2 is 13. 48 divided by 2, 24. The least common denominator for that, by the way, would have been 24. 8 times 3, so 3 times 3 is 9. 6 times 4, so 1 times 4 is 4. 9 plus 4 is 13 24ths. So finding that least common denominator does make it easier. But just finding any common denominator will still work. Okay. Don't want to spend too much time working with just fractions. I want to get up to mixed numbers. Something like 3 and 3/8 plus 5 and 1/5. Now again, I tend to work vertically. So I'm going to write it like this. 3 and 3/8 plus 5 and 1/5. You'll notice I wrote that out with just the fraction sitting on the end of each number, kind of like it's just the last digit of each number. Because in fact, that is exactly what it is. The fraction is just the last digit at the end of each number. Now, I still have to have common denominators. So my whole number portion isn't going to change, but I do have to rename the fraction. What is my common denominator going to be here? For 8 and 5. 40. What's going to go up here? 15. Good. It was 8 times 5 to make 40, so 3 times 5 gives us 15. What's going to go down here? 8. Good. 5 times 8 makes 40. 1 times 8 makes 8. So now we're going to add. Now, just like with whole numbers, we start on the right and we work our way back to the left. 15 40ths plus 8 40ths? 23 40ths. And 3 plus 5 is 8. Good. It doesn't always stay that easy. We can have something like 7 3/4 plus 6 5/6. That fraction is still just the last digit of a number. What's our common denominator going to be? 12 will do it. What's going to go up here? 9. Good. 4 times 3 to make 12. 3 times 3 makes 9. What's going to go up here? 10. 6 times 2 to make 12. So 5 times 2 makes 10. Now we're going to go ahead and add 9 twelfths plus 10 twelfths is 19 twelfths. Now we look at that, and there's a slight issue there. It's an improper fraction. We can break that down into 1 7 twelfths. Very good. Now I'm going to stop there. Any questions as to where that 1 7 twelfths came from? Took out the one whole thing, that took out 12, there's 7 left over. Now, just like we would with any other addition, we're going to keep part of it and we're going to carry part of it. I'm going to keep the fraction because this is the fraction column, and I'm going to carry the 1. Now 1 7, 8 plus 6, 14. So 4, and we carry over the 1. Not so bad? Let's do one more. In fact, I'm going to have you guys do this one in your notes. We have 286 2/3. 197 4/5. Add those together in your notes, and we'll go over them here in just a second. Okay, what is our common denominator going to be? 15. What's going to go up top here? 10, and down here? 12. Good. Are there any questions as to where those numbers are coming from? We're good with those? Okay, good. So next, 10 plus 12, 22 15ths. Of course, that can be split up into 1 7 15ths. So we keep the 7 15ths, carry the 1. 1 6 and 7 make 14, so 4, carry the 1. 1 8 and 9 make 18, so 8, carry the 1. 1 2 and 1, 4. 484 and 7 15ths. How have you had that? Anybody have questions on how we got it? Okay. Next is subtraction. We said subtraction follows the same rules as addition. So when we subtract, we still need to have the same name, or the common denominator. I'm just going to write it out that vertically here. 3/4 minus 1/8. What's our common denominator going to be here? It's just going to be the 8. It is possible for one of the denominators to be our least common denominator. Here, 4 goes into 8, so we can leave the 1/8 as just 1/8. 3/4 becomes how many eighths? 6. Good. 4 times 2 to make 8. 3 times 2 makes 6. Now we'll just subtract. 6 minus 1, 5, and we keep the same name of eighths. Well, we're not going to waste too much more time with simple fractions in our subtraction. We're going to jump up to the mixed numbers. 9 4/5 minus 2 1/6. Just like before, we need to find a common denominator, which is going to be what? 30. Very good. What goes up here? 24, and down here? 5. Good. Just like whole numbers, we start on the right, we work our way back to the left again, treating that fraction like the last digit. 24/30 minus 5/30. 19/30. 9 minus 2? 7. Good. Well, you might notice a pattern developing with me. It doesn't stay that simple, because we can run into things like this. 9 1/3 minus 2 7/8. Again, we need our common denominator. The common denominator will be 24. This top fraction is going to become 8. 3 times 8 is 24, so 1 times 8 is 8. The bottom one's going to be 21. Good. 8 times 3 is 24, so 7 times 3 is 21. We go to subtract. 8 minus 21 can't be done, can it? Just like with whole numbers, we're going to borrow. We'll borrow from the 9. That becomes an 8. Now here's the thing. What we borrowed was one whole object. How many pieces does that whole object have in it? The denominator tells us 24. That one piece has 20. That one whole object has 24 pieces in it, however many the denominator says. We're going to add that to our numerator of 8 to get 32 24s. So you add the denominator, whatever value the denominator is, gets added to the numerator. Now we can subtract. 32 minus 21 is 11. What's my new denominator? Still 24. 8 minus 2 is 6. Let's do another example of that. Oh, let's do 48 and 3/8 minus 43 and 3/8 minus 47 and 11/12. What's my common denominator going to be? 24 will do it. What's going to go here? 9. Good. 8 times 3, so 3 times 3 is 9. What's going to go here? 22. Good. 12 times 2 to make 24, so 11 times 2 is 22. Then what? Yeah, we can't do 9 minus 22, so we'll borrow from the 3, makes it a 2. What do we do here? We add 24, which will give us, careful, 33. So 33, I knew what you meant. 33 minus 22 is 11 over 24. Now 2 minus 7 can't be done. We'll borrow from the 4. That's a 3. This is 12. 12 minus 7 is 5. 3 minus 2, 1. So 15 and 11 24. What do you think? Better than a sharp stick in the eye? For now. Let's look at multiplication. We have 1/4 times 2/5. Do we need to change them to common denominators? No. When we multiply and divide, our big rules, remember, we do not need the same name. And we'll combine the counts as always, but when we multiply or divide, we're going to also combine the names. So here, I do not need common denominators. I am just going to combine the counts. 1 times 2 is 2. 4 times 5 is 20. What should I do next? Simplify. Both of them can be reduced by 2. What's 2 divided by 2? 1. 20 divided by 2? Get 1/10. Some of you might be looking at that about now, wondering, why didn't he cross cancel? Others might be wondering about now, what's cross canceling? Well, what we do here is give 1 times 2 on top, and on bottom is going to be 4 times 5. We notice that in the numerator, we have the 2, and in the denominator, we have the 4, and both of them can be divided by 2. So what we can do is, before we can divide, we can cancel that out. What is 2 divided by 2? 1. What's 4 divided by 2? 2. So now when we multiply, it's 1 times 1, which is 1, and 2 times 5, which is 10. So cross canceling is basically reducing before we multiply. Now in a problem like this one, it's probably about the same amount of work either way. But you can run into a problem like this one. 24 25ths times 35 36. You can go ahead and multiply this out. 24 times 35 is 840. And 25 times 36 is 900. And you can reduce that. Everybody sees that both of those can be divided by 60, right? Okay. We could reduce it. It wouldn't be real fun, but we could reduce it. Or we could look at this and say, what can cross cancel here? 24 and 36 can both be divided by what? 4 would work, 6 would work, 12 works. Let's say we didn't see the 12. 4 was the first number that was said. Let's do that. What is 24 divided by 4? 6. 36 divided by 4. Careful. 9. Right? We look at that, we see both of those can still be divided by 3. What's 6 divided by 3? 2. 9 divided by 3? 3. So it reduces down. It's the same as if we would just divide it by 12 right away. So again, you don't have to find that largest one. You can keep going step by step. Now 25 and 35 can still both be divided by 5. What is 35 divided by 5? 7. 25 divided by 7 is 5. So now we have 2 times 7 is 14, and 5 times 3, 15. It's all reduced. Now, to be honest, up here, if I did try to reduce this, I'd say they end in zeros. So I'll divide by 10 first. It's 84 over 90. You don't even really have to divide by 10. You can just cancel out the 0. Same as divided by 10. Next, I see that they're both still divisible, but they're both even, so I can divide by 2. 84 times 2 is 42. 90 times 2 is 45. Bless you. They can still both be divided by what? 3's, yeah. Remember, 4 plus 2 is 6. That's divisible by 3. 4 plus 5 is 9. That's divisible by 3. 42 divided by 3 is 14. 45 divided by 3, 15. I get the same answer. I just think it was easier to do this where I reduced first. Now, we're not going to spend any more time multiplying simple fractions. We're going to go to mixed numbers. We'll do something like 3 1/4 times 7 3/5. How do I multiply mixed numbers? Well, the process is extremely difficult. In fact, I used to offer this until somebody actually did know how to do it about 2 years ago. I used to offer this that if you could show me how to actually multiply mixed numbers correctly, I'd give you an A for the unit and you could skip the next 2 weeks and come back after the unit test. Somebody actually did it a couple of years ago, so I don't do that anymore. But in 17 years, I've only had one student that knew how to do it. Does anybody here know how to do it? All right, what you're looking at, we avoid multiplying mixed numbers because the process is extremely difficult. So what we do is we turn them into improper fractions. 3 1/4 becomes how many fourths? 13. There we go. 3 times 4 is 12 plus 1 is 13. 7 3/5, 38 fifths. Yeah, I'll show you in a minute. Here we can cross cancel the 4 into 38. It's still multiplying, we can cross cancel. Both of them divided by 2, so this will be 2 and 19, right? 13 times 19 is 247. 2 times 5 is 10. And we need to reduce that. 247 divided by 10. 10 does not go into 2, but it goes into 24 twice. 2 times 10 is 20. Bring down the 4. Or left with 4. Bring down the 7. 10 goes into 47. 4 times 10 is 40. There's 7 left. So the remainder of 7 is going to be written as 7 over that denominator of 10. So that is 24 and 7 tenths. This process takes a while of converting that improper fraction back into a mixed number. It takes a little bit of work, but it's much easier doing it that way than what I'm about to show you. I'm going to show you, don't write this down. I'm never going to make you do this. But what I'm about to show you is how you would multiply that as mixed numbers. So 3 1/4 times 7 3/5. Now remember when we multiplied whole numbers, like 42 times 35. The 5 here has to multiply the 2, but it does also have to multiply the 4, doesn't it? Same here. 3/5 will multiply 1/4. 3/5 times 1/4, 3 times 1 is 3. 5 times 4 is 20. But the 3/5 also has to multiply the 3. How do I multiply a fraction times a whole number? I put the whole number over 1. I make it 3 over 1. Now it's a fraction. So 3 times 3 is 9. 5 times 1 is 5. 9/5 would be 1 4/5. Now I move over to 7. I've got to do 7 times the 1/4. Again, I turn the 7 into a fraction by putting it over 1. Now I multiply the numerators. 7 times 1 is 7. 1 times 4 is 4. 7/4 or 1 3/4. And then finally, I just have the 7 times 3 here. 7 times 3 is just the 21. Now I need to combine these things here. To do that, I need a common denominator. It's going to be 20. So the 3/20ths doesn't change. 1 4/5 will become how many 20ths? 16. Good. 1 3/4 will become 15 20ths. Of course, 21 doesn't change. We have 3 and 6 is 19 plus 5 or 15 is 34 twentieths. That is 1 and 14 twentieths, right? We'll keep the 14 twentieths, but both those divided by 2, so it's 7 tenths. You see how I got from 14 twentieths to 7 tenths? Any questions? Divided them both by 2. I'm going to carry the 1. 1 and 1 is 2, plus 1 is 3, plus 1 is 4. And then we got the 2. 24 and 7 tenths. I get the same answer. I'm probably going to stick with the improper fractions, right? Let's show you another example of the improper fractions so that you're not confused by that mess there. Let's go 3 and 5/8 times 1 and what's that? Let's go 1 and 3/5. Tell me what to do. 29/8. Good. 3 times 8 is 24 plus 5 is 29/8. 8 over 5. Very good. 1 times 5 is 5 plus 3 is 8/5. Then what? And cross cancel or cross simplify. The 8's both divide by 8. Well, 8 divided by 8 is 1 both times. So just 29 times 1 is 29. 1 times 5, 5. So 29 divided by 5. 5 goes into 29 how many times? 5. 5 times 5 is 25, so there is 4 left over, so 4/5. 5 and 4/5. Yes. If you look at this and you can figure out that that is 5 and 4/5, yeah, that's fine. I just do the long division because that's one visual way of breaking it down. Well, let's look at division. We multiplied just straight across. We said that division follows the same rules as multiplication. So if I have 12 25ths divided by 4/5, can I just do 12? Can I just do 12 divided by 4 is 3? 25 divided by 5 is 5. Is that right? Is that the right answer? Everybody's looking at me. It actually is the right answer. Does that work every time? Sure does. Why don't we do it that way? Well, because we run into things like this. 3/4 divided by 2/3. If I try to just divide straight across, 3 divided by 2 is 1.5. 4 divided by 3 is 1.333333333. It keeps going on, right? It doesn't work out nicely. Well, how have you been taught to do this? Well, the operation operates on the number that comes after it, right? Instead of dividing fractions, we do what? We multiply by reciprocal. So times, instead of 2 over 3, it'll be 3 over 2. That is called a reciprocal. So now 3 times 3 is 9. 4 times 2, 8. So 1 and 1/8. Well, believe it or not, this process came from this up here. Again, this is one of those times where you can set your pencil down if you want to. But I'm going to show you how this was done. 3/4 divided by 2/3. Once upon a time, they would rename this first fraction. The way they would rename it is they would look at the second fraction. Take the numerator times the denominator. 2 times 3 is 6. So we're going to take that 3/4 and we're going to rename it by multiplying by 6 over 6. What is 3 times 6? 18. 4 times 6? 24. 18 over 24 is equivalent to 3/4. We've just renamed it. Now, divide by 2/3. What is 18 divided by 2? 9. 24 divided by 3 is 8. 9/8 or 1 1/8. It's the same answer. And I wonder, how did we get from this to just multiplying by reciprocal? It's not as big of a leap as you might think. At some point, someone looked at this, 3/4 times 6/6, and divided by 2/3. Because that's basically what it ended up being. They were looking at it and said, hey, if we stretch the rules a little bit, if we divide here first, what is 6 divided by 2? 3. What is 6 divided by 3? 2. And what they notice is what they get here is always just this fraction flipped over. So they called that, they gave it a name, the reciprocal. And then all that's left to do is the multiplication operation there. So when we're multiplying by a reciprocal, what we are doing is we are skipping over all these steps up here. That's all it is. So what if I have 5 1/2 divided by 2 2/3? Well, it only makes sense that if I'm going to turn it into multiplication, that I'll do the same thing I did with multiplication. I'm going to turn them into mixed or to improper fractions. 5 1/2 becomes 11 halves, right? 2 2/3 becomes 2 times 3 is 6 plus 2 is 8/3. Can I cross cancel the 2 and the 8? Say no. Why not? Because it's still division right now. What do I have to do to make it multiplication? Reciprocal of which one? The 8/3, the one that comes after the symbol. The symbol operates on the number that comes after it. So yes, it'll be now times 8/3 becomes 3/8. Now I could cross cancel if there was anything that did. Right now, unfortunately, there is not anything that cross cancels. 11 times 3 is 33. 2 times 8, 16. 16 goes into 33 twice with 1 left over. Any questions? Okay, well, I think you guys have had enough for today. We are going to look at, in the little book, unit 6, 7, 8, and 9. And of course, just the odds. As always, skip around a little bit if you want to. Do the first couple. If they're easy, skip